So, good afternoon, everyone. Thank you very much for the opportunity to present today. So, first of all, I'd like to do a few caveats. So, I'm not a BIM expert, and I'm not a building and construction expert. So, you might ask, why am I here? What use am I? And the answer is, well, I know a fair amount about artificial intelligence. And in the age of internet, where you can go online and probably get a good feel for all the different disruptive technologies that are out there, I thought it might be interesting to highlight a few of the relevant points to this area, to this community, and also to connect the dots about what it might be able to do when they're all put together, and also what are some of the obstacles that are going to maybe get in the way in us being able to do this in a time frame sooner than later. So I guess some statistics. Deloitte recently had a study where they said 70%, 76% of business leaders across a vast amount of industries agreed that there would be a major transformation to their businesses due to AI or thanks to AI within 3 years. So that's a very compelling statistic. And I think in terms of societal changes, we can see the use of AI to detect diseases and to prevent epidemics and pandemics. And we can also consider the use of drones for delivering artificial organs and for inspecting buildings and for anything, and drones that will be controlled by mind headsets instead of using controls. And we could also consider the fact that AI will help to find missing children, which is actually a huge problem in countries like India. And so I think the point today isn't just to say what we'll be able to do for the area of smart building applications. It's to say what we'll be able to do in general and how this applies to smart buildings, and also what are the next steps in order to make this a reality. So in terms of what we call smart building applications, first disclaimer, no large companies have been mentioned in this presentation, and none of the comments in this presentation are directed at large companies. As I presented this to colleagues, everybody had an idea of who was targeted, but especially since the next speaker, I believe, is from one of the major players. So across the project lifecycle, we all know there's analysis and planning, et cetera. We don't have to go through these. The idea is, how can we use artificial intelligence to not only to perform each of these steps in a more efficient and productive way, but also how can we connect them so it can be a fluid process. So, we can see that building information modeling is at the center of this. That's the whole purpose of the conference, so I won't speak too much to that. In terms of disruptive technologies, there are lots of disruptive technologies. We can talk about additive manufacturing, specifically for this community, and we spoke about it at lunch today. We could talk about smart materials, autonomous robots. We could talk about smart sensors, 5G, artificial intelligence in general, and virtual reality and augmented reality. I chose to focus on the last four. The assumption, the guiding assumption of what I feel to be the most important aspect of how AI is going to maybe be a transformative element to the building and construction industry is that it will allow for comprehensive automated workflows. So the idea is that everything should be a workflow, and they have to be automated, and they have to be comprehensive. Okay. So there's a lot of information in these slides. I won't go through all the slides. The idea is to highlight some of the main areas that I think are important, and also to provide a slide deck that might be useful afterwards to those who are interested. So if we look at smart sensors, this isn't the format's not right, but. So if we look at the four areas of disruption together, smart sensors, 5G, and then we look at the information extraction in near real time and also information dissemination. And then we look at the fact that we can use augmented reality as a way to interact with the data that we've transformed. And in addition to that, some of the interactive technologies that have recently become available, what we can see is that, in fact, AI is present in all of these. In fact, AI is even present in the 5G communication technologies in order to avoid overloading of networks and to handle cyber threats. And so the idea is that, yes, this is a digital value chain, but the idea for BIM is that it will become a collaborative, automated, near real-time digital value chain. And I think that's at least the near-term or mid-term goal of the transformation. So this is, the building smart folks really, I think, have captured the essence of what's needed in terms of standards to do what we just said. And so if we look at the main elements of the focus of level 3 and beyond, there's the workflow BIM, the cloud BIM, and then the linked data OWL RDF version. So I think I wanted to give a credit to this organization, and not only in having all of the sufficient and necessary elements, but also the appropriate focus on those. And so it's a quote that at levels 3 and 4, the importance of data being searchable by both humans and machines will be crucial. I agree with that, and I think that this is going to be the next major breakthrough, I think, in terms of developing the BIM standards. So, there's the building smart folks, and there's also the BIM bots. And so the BIM bots is actually pretty cool. These are things that we can do in the near term, and that will help us to automate our processes and to be able to interact better with our data. So this is a way to highlight the fact that, and I'll just read it, open standards are essential, but two-way interoperability ensures that useful information is shared in a timely manner. So it means the standards aren't just there to help us to do things, to get them into a given workspace. They're also there to help us get data to the next step. And I think that the standards right now are there. How they're being used, I'm not convinced that this two-way interoperability has been addressed as much as it needs to. And we'll talk about that a bit more. So in terms of smart sensors, just to give an idea, and I don't think this is new to this group, there's concrete measurements as the concrete is curing. There's RFID tags that can be put and are being put everywhere. There's a bunch of sensors that can collect data as construction is occurring or afterwards for compliance testing, conformity. So we have low-cost LiDARs, and there's one out there. I saw it before I entered the room, and it's amazing what you can do for under $20,000. I think it's a self-contained model generator. There are trucks. There's a Montreal company that created a truck that can actually go and it does go around from city to city, collect data and build virtual, twin models of cities. And then there's drones, and so this is my particular area of expertise. So we take data and we actually transform it real time, and then we generate models that we can communicate to other sites. So this is an example. The fact being that the ability to have data which is pre-processed and even processed at the source just makes it easier to generate those automated workflows. So 5G technologies, what does this mean to this group? Well, immersive gaming and augmented reality were two that were on this list that is not my list. But immersive gaming also means anything that's simulation related that allows for a stakeholder, including end customers, to interact with the data that's been transformed. And the fact is, there's been an order of magnitude increase in how data can be communicated, and it's going to continue to increase. And so as we go from a few minutes to download let's say a 4.5 gigabyte film, we're going to go to a few seconds. And so that might be fun to watch movies, but I think this is going to be a real enabler when it comes to communicating different pieces of a complex architectural project in real time, and will be an enabler for collaboration. So at the lunch table today, we agreed that collaboration was not what it could be and not what it needs to be. So in my mind, this is an important enabler. It brings connectivity. It also brings reliability and performance. So it's not just fast, but you get all the pieces of your model in the right order, and et cetera. So AI-wise, as AI has become more popular, when I started working in the area of artificial intelligence, we didn't call it that. And when you explain it to your friends and kids, nobody cared. So now everybody cares, and everything has become AI. So a lot of these areas that I put up here are now considered part of the AI world. And there's really 4 categories that we can talk about. And I'm not going to go through all the sub bullets, but we could talk about human interactions, how we can speak and how we can make gestures and interact with machines so they know what we want. How we can use AI to change our organizational processes and the way we work together to accomplish our business goals. How we can use machine resources to do specific tasks, find the crack or find the person or determine, compliance. And we could also talk about how we could use AI just to present things in a way that they're easier to assimilate or easier to interact with. So I'm going to now try to present a short history of artificial intelligence in 4 bullets. Yeah. So when AI started to really gain steam, there was its infancy where people were saying there's no AI without data. And at the Computer Research Institute of Montreal, we have many customers, many clients who want to do AI who have no data. So that's kind of a showstopper. I think there's been an evolution, or there was an early evolution. So for those who thought AI was masculine, I put a girl. So for all the sexists. So. The evolution was to say there was no AI without structured data. So not only do you need data, but if the data is not structured to start with, you need to add structure to it so you can do something with it. The third step would be to say, well, there's no real AI until the data is fixed. So it may be structured, but you have to present it in a way where the different algorithms and the different processes can act on the data to transform it in a way which makes sense. So this was a recent shift in our understanding. And now, well, if we say that AI has reached a bit of maturity, we can say that the future of AI is about less data. And Emily this morning talked about data management for BIM, and a lot of the points I'm making she made in a different way. But the idea is that there's going to be a lot of data. But what we need to do is to distill it down such that the data that we communicate and the way in which we transform it doesn't generate unnecessary data, and we don't use data that's not required for the processes. So I think this is the current state of affairs, and I think it's quite relevant to this group. So this is a very confusing slide, which basically says that there's 3 kinds of data. There's data which is unstructured, so video, images, free text, audio, emails, and there's data that's structured. And so the difference is that structured data, there are explicit relationships. These are databases, these are linked data. This is the data that we often don't have the luxury of working with as engineers. And basically it's 80% of the data out there that's unstructured. Only 20% is structured if you look at it. The data that machines need to analyze is structured. So if it's unstructured to start with, an image, it's going to be transformed into a bunch of pixels before it's processed. The reality of things is that there's a lot of partly structured data. And the partly structured data, it means that the meaning is implicit. It's not expressed through relationships that are well-defined and mathematical in nature. So we have spreadsheets, XML data, JSON, and things like that. And so what's interesting to this group is that the IFC is actually a semi-structured data set. And the idea of going from IFC to IFC OWL or Express to OWL is to actually benefit from all the advantages of having explicit relationships. So an example is if we had a BIM model that had all these explicit relationships, we could ask the BIM model, what are the potential emergency exits in case of a fire that would take place at this location in the building? Some of the things that go beyond saying what percentage of the windows are, of a certain quality that you can do today, right? So if you want to ask intelligent questions to a comprehensive BIM model, then you have to give it the structure that allows for you to ask those questions. So I promised I would teach everyone what machine learning was in 3 slides. So I have 10 minutes left, is that right? All right, I'm talking fast, that's not always a bad thing. All right. Okay, so machine learning. There's 3 basic categories of machine learning. There's supervised, unsupervised, and reinforcement. So supervised learning means taking very structured data and teaching an algorithm how to interpret that data and how to extract the useful information we need from that data. So this is typical prediction tasks, and this is what most people, when they talk about machine learning, are referring to. Unsupervised machine learning means you basically have data. You don't know you don't have the ability to act on it. So what you try to do is you analyze it in a very statistical way and try and regroup it. So you may not even know what's inside it, but you can still work on it and regroup it. So you do things like identify structures and clusters and so forth. And there's reinforcement learning, which basically means a person is in the loop and he's going to try and guide the model to learn from its mistakes. So that's not the focus of the current presentation. If we talk about supervised learning, it means you have data, you use part of the data to teach the model, and use part of the data to validate the model. And then as you have a problem, you try and use your predictions to update the model to make sure it's working properly. And the idea is that the data must be structured before you start to train. And if you look at unsupervised learning, basically you're taking raw data deriving a model, and then using that model to make predictions. And the idea there is that the data structure is extracted during learning. So these are big differences. And as Emily pointed out this morning, part of if I understand correctly what she said, part of what we want to do is move towards more structured data because it allows for us to do more things, and we can even use artificial intelligence to take the unstructured data and make it structured. So this is very much in line with what the Linked Data Working Group is doing in Building Smart. The work that they're doing for the future, this future standard, I think is going to be an enabler to do just that. And if we can take all our data and add structure to it, it'll only make it easier to transform that data in these comprehensive, collaborative, near real-time automated workflows. So to reap the benefits, at least many of the benefits of these future AI-enabled smart building applications, data needs to be implicitly structured or explicitly labeled. So using these algorithms to label data is a way to add structure. So there might be AI experts that would disagree with me. And in some instances, you can say detecting cracks using deep learning is an unstructured task, and et cetera, et cetera. So this is not, some of this is my personal opinion. So we can fight about it after the presentation. So this is, the data is the new oil slide. And in fact, the thing that's important here for this group is that the different activities involved in refining oil are pretty much the same that would be involved in a BIM workflow. And so there's the extraction, the pre-processing. You need to do an intermediate transportation. Then you need to process it, and it could be a medium level, refinement or a high refinement. You need to deliver it, and then it gets consumed by the end user. So for the BIM world, yes, there's data collection using smart sensors and tags and so forth. Then there's processing, when you do validation and corrections and conversions. The communication is the transport, so it can go to using edge networks to cloud storage and other forms of data transportation. You act on that data using data analytics and other things in the cloud, and so you can take unstructured data, structure it, and then do what you need to do such that you create your information products, you share them, and then you have the consumer. So in terms of the consumer, I think the idea here is that, yes, you can have a machine that takes the data and does something with it, or you can have a human who interacts with that data for the purposes of validation, refinement, customer acceptance, conformity, compliance, et cetera. The most important point here is that data must flow. And I think that this is a point I can't overemphasize in that today, if there are shortcomings in the standards, number one, it's probably that they're not applied broadly enough. And the other is that there are maybe some kinks that we need to work out to make sure that data can flow, at least in the pre-BIM to the post-BIM, say, steps, such that these automated workflows actually can occur in a near real time, or at least in a continuous fashion. Okay, so here are some points that I think are quite important for this group. So I'm going to go through them. The first one is automated workflows are no longer an option. They are missing because my slide is not the proper. That's okay. I think I know what so they are required. Automated workflows are no longer an option. They are required. If we don't have them, our processes will stall, and they will be the source of delays and miscommunications, and they will be an obstacle to collaboration. So they need to be automated. Second point is that machine learning, yes, it's going to be very useful, and it will be useful in particular also in transforming unstructured data to structured data. So we have to understand what that means. So for the business leaders here, they have to ask their technical people, is our data structured? Does it need to be? And for those who are technical people, they probably would agree. So deep learning is a subset of machine learning. And so just to demystify it, the main applications for deep learning with respect to the building and construction industry, detecting anomalies, also object identification, object detection, object identification in terms of if something is built as it needs to be in a specific instance. The standards. Standards are both an enabler and an obstacle to achieving automated workflows. So now I have to go back to my notes to make sure I don't get this one wrong. My notes are not open. So what that means is If the standards work properly, everything will flow. If the standards don't work properly, everything will stop. The technical interoperability side of things, the technology in the form of the standard needs to be an enabler and not a corporate business model or a source of competition among stakeholders. So it's very complex when we have a standard that we try to promote because everybody has a different relationship to that standard. The regulatory bodies have a relationship to it, the customers, the tool manufacturers, the tool users, et cetera. And so I think the challenge is to make sure that, for example, the interoperability standards are adopted in such a way that you can, for example, get data in and out of applications as required to animate the workflows. So here's an example of a product. So this was captured by Jakarta. They use their truck and they go through a city and they stop and they collect data and they process it and they move on. So they have the ambition of mapping out all of Canada, at least all the cities in Canada, and they've started. And so what's particular about this data set, which I think is representative of data sets to come, is that they're going to be higher and higher resolution and accuracy, and also more voluminous, 3D structured and geolocalized. The GIS data is going to be integrated. So it means not only do we need to take into account the standards that we're developing, but we need to take into account the standards from other bodies, the geospatial folks in particular. And I can see that's happening. And they're also multi-sensor. So we're fusing images which are LiDAR-based with photography and perhaps other means as well. In this case, I believe they have environmental sensors. So they might be detecting environmental parameters at the same time as they're trying to determine if the sidewalks are compliant with what's required for wheelchair access in front of a given building. So the applications, again, object recognition, object detection, anomaly detection, compliance, visualization, and VR applications. Which brings us to 3 things you can do. Well, you can use AI to detect changes in the data and indicate if there's a reason to be alerted. You can use the AI system to analyze photographs of a structure and indicate whether it's in line, whether a line is a crack or if it's something else. And you could use it to explain how invisible algorithms of AI systems arrive at their recommendations. So if the system says something crazy, you can go back to the model and say, well, actually, it does make sense. There is something wrong in this area. So a few words about virtual reality and augmented reality. I think I might just make it. So I have a few minutes left?
No. 5 minutes.
Okay. So virtual reality and augmented reality. Let's go this fast. So there are a lot of virtual reality and augmented reality products out there. The most prevalent are the virtual reality headsets and goggles. There's also iPads and tablets that provide a view that can be altered with augmented reality information. There are these kinds of circular displays or even wall displays. And then there's the domes and the caves. And so the idea here is that most of these are already available. And I apologize for the formatting error, but the slide was made in a larger format. So there's a lot of these that are already available today. Most of them are low cost, at least the headsets. But the headsets, which are the most prevalent, don't really they don't apply to all the applications. And there's gaps that are still there. So one of the questions is, well, what's wrong with the headsets? And the answer is, well, you can use them for a small amount of time to solve a lot of problems, but they have depth perception limitations. You get dizzy and headaches and seizures sometimes, and usually you can only use them for less than 30 minutes. And that's not me who says it. It's actually the manufacturers who say that. So if we look at a different approach, if we look at what we call realistic 3D immersion and intelligent adaptation and interactivity, which is missing from the slide, we have an environment which some of the people at the conference were able to visit yesterday. And in fact, what you see is that you have a 3D experience which allows you to actually interact with your environment. So here we can talk about real-time fusion. You can talk about realism and duration of use in an operational context. And you could talk about the interactivity and the intelligent interface. So I'm not going to go too much into detail about the multimodal interfaces and voice commands, but I will finish with a conclusion slide. This is, as a conclusion, I thought I would show a real project which is proposed. I just need another 30 seconds. And so this project actually is a collaborative, real-time, automated workflow. So we have the Jakarta truck collecting LiDAR data with an embedded resource, which is processing that data. It's also receiving 4G feeds from a drone for pictures above a building. So the truck is taking pictures around the building, and the drone is taking complementary data above the building. That's being communicated over a 5G network, and that goes into a 3D immersive station, which further processes it and adds information, including augmented reality information. And so this is what we call a 5G edge computing data collection and information sharing infrastructure, and it very easily could be one that would apply to many smart building applications.
Thank you very much.